Hey everyone, Mark from Coast Country. Today's video I'm going to start doing some wiring to get this isolator in the boat. I'm going to make up a wiring loom, so I'm going to at least get the main feed into this and possibly an Anderson plug for the trolling motor. Well, I've got a few bits and pieces for our wiring to start with. I've got some 8mm squared cable, which will be straight from the batteries with some decent terminals onto there. I'll run that through a circuit breaker, which is resettable. Unfortunately, I could only get a 50 amp circuit breaker at the time. Mate's an auto electrician and he swears by this brand. He reckons they're better than Nava. So anyway, and they're a bit cheaper too. So anyway, we've got a 50 amp one. If I find this trips out, which I'll be amazed if it does, I'll change that over to a slightly heavier one. This cable's rated at 100 amps apparently, but when you read it properly, it's at a 60% duty cycle for 5 minutes. So realistically, it's probably only good for about 80 amps, something like that, which is going to be plenty for what we're doing, because this outboard electric motor, if we ever get one, I think they're rated worst case scenario at 50 amps. So anyway, and we're also putting a 50 amp Anderson plug. So this goes from the battery to our isolation switch. And I'm actually using this as a, like I said before, as a single battery. So when I flick it to 1, it'll be connected to the trolling motor. If I go to 2, it'll connect the battery to the control panel and the charging circuit for the outboard. So if I want to use both, I can just click it to 1 and 2. So anyway, so when I click it to 1, I'm going to run a short cable of this to an Anderson plug, ready to plug the new electric into it when I get one. Other than that, the rest of the cabling I'll be using, it's a bit of an overkill as well. I'll use this, I think it's 4 or 5mm cable, I can't remember now. It's probably written on here. I'm going to run that to the control panel, which is a total overkill considering from the control panel it's only going to have LED lighting, so I could use heaps skinnier stuff and I still might yet. And on that circuit to the control panel, I've got a 20 amp circuit breaker, which will be right near the isolator as well, so if something shorts it'll trip that out. And they're resettable as well, and the control panel's got its own fuses as well. So, alright, we'll get into it. Well, so I had a piece of old chopping board lying around the shed. What I want to do is use that to mount these circuit breakers that I can get to. So I'll mount these in the battery compartment that we made in the floor of the boat. I'll mount them on a bit of nylon block, obviously, so we don't get a reaction when we screw these onto the aluminium. So if I do it like this, it'll also keep a bit of weather off it. Also, if there's a major problem, I can actually access these, take a terminal off the battery lead and put it onto the circuit breaker and basically bypass this if I have to. Not that you recommend doing that, but anyway, it just gives me access to things if things go wrong and I need to get power from somewhere. Anyway, so I'm just going to cut this out and get this mounted on the aluminium and screw them on, and then I'll mount the wiring. Well, I've just cut that out with the angle grinder. Just get your favourite deburring tool now. You just go around the edges, take any bits off. Alright, we'll get these drilled and mounted on there. So that's the little circuit breaker mount we've made, just a bit of chopping board. So anyway, we'll get that screwed into the boat, into some aluminium, so there'll be no corrosion problems. I can access these. That's the 50 amp breaker, that's the 20 amp. I may have to up this a bit if for some reason that trips out with the trolling motor, I'm not sure, but we'll worry about that later. It's really easy to get to if I have to. So we'll get that mounted. Right, I've decided to mount this just under here. Could have mounted it there, but then it sticks out a little bit closer to where the battery drops in. So I've decided to mount it back under there a little bit out of the road. Alright, nice and solid, and it's out of the road, so that's where our terminals will go. So what I'm going to do here is just work out the wiring for this this really heavy cable, which is our main power feed. So what I'm going to do is just thread this through. I'm actually going to run it behind the glove box here with a bit of conduit. Not the glove box, the fire extinguisher box, I should say. And so what we're going to do is we're going to have this cable. This heavy cable is going to run to the isolator switch, and then from the other side of the isolator switch it'll run across to the back here where there's an Anderson plug that's going to be for the electric motor. So what I need to do is just basically mark a few things where we need to cut cables, etc. What I'm going to do is I'll splice this cable out here and I'll cut the positive wire, the red one, and then I can put one side of it onto the main feed where the battery goes, and number one on the battery isolator will then go to the trolling motor, but the earth lead will go continually to the motor. So what I'll do is just wrap everything in painter's tape first and mark everything. Say I need to cut this and that to solder on whatever terminal, and then I can just go and make it on the bench and then feed it all through. Back here there'll be a couple of terminals on the positive feed again going to the 50 amp circuit breaker, which I can change out to a bigger one, and on the other end of this cable I'll put the heavy terminals where the battery terminals will go as well. So it's quite a short feed, but you have lots of power. The shorter the lead you can have, the better when you're pulling a bit of current, and especially because I've only got one battery. If you've got dual batteries, it's a different story, but anyway, that's what we'll do. We'll mark all this up and then I'll start putting some terminals on. So I've worked out where we need all our cables and connectors and things. So this is our cable, just strip the end back. You can either use a Stanley blade or I use side cutters. And then we're going to solder these Anderson plug connectors on the end like so. And I'll do that in the vise, and what I do is I get them really hot, melt some solder in there and drop the wires in, and they hang on pretty well that way. Doesn't matter which way these terminals go at the moment, because you sort out the polarity when you put it into the actual housing. They snap in from the back of the plug anyway, so we can sort that out in a minute. So with these Anderson plug terminals, you can use map gas to get a fair bit of heat into them quickly, melt the solder, and then put the wiring in. Or you can use these little gas burners, these little things here, which is just little flame runs on butane. It's probably a little bit more of a controlled heat when you use this. Map gas is a little bit hot, but it does the job. What I do is just get a bit of solder, quite a bit of solder, double it up, and just wrap it around, so you're just doubling up the solder that you're banging in, otherwise you'll be there for a little while. There's multiple ways you can do this. You can use a scope soldering iron, which has got quite a bit of heat. Gas soldering irons as well is another option, but I just found this is quicker and it gets a nice lot of heat into there quite quickly. So what we do is you get your favourite Anderson plug, start heating it up, and just start feeding the solder in. When that terminal gets super hot, it'll start sucking in solder. If you put it in a vise, you're not going to melt anything else. You don't want to overheat this either. You can actually burn solder if it's too hot. So you can see that's still feeding in. Map gas, you just got to be on and off with this quite a bit. There's a fair bit of solder in there at the moment. You can see the flux all coming up to the top. So that's pretty full. Keep that warm. Just do a little bit of a preheat on your wire. When it's hot enough, that'll flow in there quite nicely. You'll see it nice and shiny. And then don't move it until it sets. You can see the solder's run up the copper wire as well, so that's definitely flowed and tinned. While it's still pretty hot, you can stretch these terminals right down a bit and then they'll set there. And then just repeat with the other one. You can pre-tin these as well if you wanted to. Just got to be careful that they don't all fray out. So by that, I mean, you can heat this up and get a bit of solder onto it. Let a bit of solder flow right through it. Don't want to overdo it because you'll dry out the solder. So that's plenty. So when we heat that terminal up, that'll slide on there, no worries. So same again, put a heap of solder in here. So this is resin cord solder, or flux core, whatever you want to call it. So it's starting to flow now. I actually prefer to use matte gas to this, it just happens so much quicker and hotter, and brilliant. So it's run out of gas, so there you go, we'll get the matte gas out. Right, okay, so we have our matte gas here. This is probably a bit of an overkill, but it does work just as well. You just got to go a little bit quieter with your heating. So just on and off the heat. This is why I double up the solder, so you can get heaps more in there quickly. This is why I like to use matte gas better. It's super shiny. There's not a dry joint in there. It flows a lot quicker. Even to the point, I'll probably just quickly give this one a little bit of a reheat. Trick is not to move while it's setting. You can start to see it set then, it's just grab now. So I like to use matte gas, gives heaps better heat, quicker, flux flows quicker. Anyway, that's we'll let that cool. So they've cooled down a bit now, you can see that's nice and shiny. It's got good flow in there, that's not a dry joint at all. So once they're cooled down, you get your Anderson plug and you work out which way is what. So positive's that one, positive's red obviously, so and they'll just snap straight in there like that. So that's ready to rock and roll, and you can put a bit of electric tape around there if you need to, good quality tape. I've decided I'm going to mount this a bit further up under the front of the boat, out of the weather, instead of on the front seat, so any sea spray and that will that'll protect it a bit then. So right, so I'll go and do the other terminals while we're at it. So I marked earlier where we needed to put a couple of terminals, and this is where we're going to tap into the isolator switch. So there'll be power coming from the battery to the main feed in, and then we'll be tapping off to either the trolling motor or the control panel. So all we'll do these, just strip back a bit of a terminal of what we need, a bit of insulation I should say. So if you keep the wires nice and straight, instead of twisting them round and round and round, you can generally get all the wires in. Sometimes you need a pair of pliers that just give them a bit of a wriggle. But you should be able to get all of them through the terminal there. And we can crimp that, and what I'll also do with these, because it's in a marine environment, I'll just solder the tips of it. So we'll just get our crimpers. Like that. And that's done. And what I'll do is I'll just solder that. I'll do this one first. So again, we get all the wires through the terminal. If you keep them all straight, they'll go through. Let's give that a quick crimp. Trim that up a bit and I'll solder the ends. So these will go on our terminals like so. So we've got the full thickness of cable all the way through. So here we had our tape where we knew we needed a couple of smaller terminals, like these ones, which is where the circuit breaker is going to go. So all we do is slice that to the Stanley blade, find the red wire, cut it in the centre, pull it out, and then you can strip back as much as you need. So this is just going to bridge this little circuit breaker we just mounted. So these terminals will just go on here. And so what that means is you've got a constant flow with your earth wire as well, with minimum breaks in any of the cables, because every time you cut an earth wire you're going to rejoin it. It's just an extra connection that can lead to corrosion and poor connectivity and cause problems. So all we'll do is these, strip these off, crimp the ends on, and that's where the breaker is going to go. So same again, you can see there's a fair old mouthful of cable there. All the strands have gone all the way through. I'll trim them off a bit and I'll solder the ends now. But that's probably the maximum amount of thickness cable you can get in these connectors. But at least you know that there's 100% all the strands are in there, so it'll allow it to have full current flow. So all I'm trying to do here is we're just sealing up the tips of this with solder. So we don't want to go crazy and melt all the insulation off. So that's crimped pretty well. That's probably not going anywhere, but being in a boat, bit of marine environment, I'm going to solder it as well. So yes, MAP gas is pretty hot, but it gets the job done really quick and you don't start melting all your plastic while you're doing it. If I was to do this with a soldering iron, you'd heat this up and take forever. It'd get so hot this will start melting. So you just need a quick lot of heat, get it done. You're not overheating the whole solder. So what you're doing is we're concentrating the heat to the tip of this, and then we're just feeding solder in at the bottom, taking the heat away. So I don't know if we can get that on camera or not, but we'll see. So just heating the tip of the spade terminal up whilst holding the solder on below it. And once that terminal gets hot enough, it'll start melting the solder. And then you're able to see it flow through. And nice and shiny, take the heat away. That's flowed down into that terminal as well. And that's pretty much it. It's just an extra little bit of connection to make sure it's going to last better in a marine environment. So I'll do another one. These are the bigger terminals for the isolation switch. So again, we're not going crazy here. It looks hot, but we're not really going too crazy to melt all the insulation. So I'll try and do that here so we see what's going on. So all we're doing is heating the ring at the top. You can see the solder underneath not even melting yet. So a little bit of heat on, take the heat away. Watch the solder, see it flow. So the heat's totally away now. You see that solder flowing through there. That's it, nice and shiny, so you know it's not a dry solder joint, you haven't burnt the heck out of it, and the insulation's not even singed on that. So yeah, I mean, it's a pretty industrial way of doing it, but it's super fast, gets the heat in where you want it straight away, melts the solder, not the insulation. Right, I'll do the other one and then I'll show you the end result. So there you have it, that's the bit that's going to go on the isolation switch eventually. So we've got our black cable in there. What we'll do now is we'll just tape that up with electrical tape to seal this off a bit. Even though it's going to be out of the weather, we'll just tape it up, stop things living in there. And then move down to this one. There's our terminals for our resettable circuit breaker. And on the other end, we need these heavier terminals. You could actually use these terminals to put this onto the battery. I'm going to go and put these ones on a bit heavier. Probably an overkill actually, now that I think of it. Maybe I will just stick to the normal ones. Not sure, we'll work it out. So this is the crimping tool we've got. It's not super brilliant, but does the job. I'll solder these up again anyway after. So that's locked on there now. Do another bit down the bottom here. Right, so that is locked on pretty well, but these terminals have got a little tiny hole down the top, and I'll heat this up and fill that up with solder as well while we're at it, just to make sure it ain't going anywhere. Okay, so that's full of solder and crimped. Right, so that's a finished loom. We just got to install that, run it through. So Anderson plug at the end, which will go to electric motor at some point, and then through here's where the terminals are, which will go to the isolator switch. And a bit further down, we've got terminals which will go to our circuit breaker, and then right at the end, we've got our terminals which will go to the battery. Right, looks like a big mess, but that's the main wiring looms done for the main power. So before I can actually run these through under the floor, I've actually got to quickly wire up a connector for this courtesy light we're going to mount right up the front. So I'll quickly wire that up and then we can start running some cables nice and neat. So this is one of the courtesy lights up the front we're going to wire up. So I just need to join this cable. This is a bit of a lighter cable, which is still absolute overkill for the current that this thing's going to draw. We just need to join these two together. So first thing we'll get going is a little portable gas soldering iron. So I'll crank that up. Just sit there heating up while we're waiting. So I'll strip a bit of this outer insulation back. Like so, and we can actually shorten this up a little bit too, so we have more of a protected cable coming out the back. So in this particular light, white is positive, black is negative. So what I'd like to do is when I solder wires together, I like to stagger them so you're not soldering the two wires right next to each other, so if it rubs through they can touch. So I always trim one a bit short. So in this case we're cutting the black wire. So in this one we need to cut the positive wire the same, so when they join they'll be the same length. That'll make sense in a second. So I'm cutting the positive wire short here. So then when I strip this back, it's pretty thin light cable, this stuff. It's very thin. These are pretty cheap nasty lights, but they should do the job. So then when I strip all these other cables back, when we join them, I'm just going to twitch these together basically like that and solder them and then tape them. What I'll do is I'll cut these back a bit further and use them as a wrap because they're so thin. So what I'll do is I'll keep the heavier cable pretty much straight. I'll just quickly solder that while we're at it. So this should be nice and hot. So when you solder, just heat up the copper first and then just feed in the solder and you should see it flow all the way through. Like that, should be all nice and shiny. So that's one. And because we've cut these staggered, so when you actually do your join, you're not actually joining the two wires dead opposite each other. Let's wrap this around for a sec. quickly solder that one on. So the reason why we cut them different lengths is when you join them, and if you take that just like that, these two connections are miles apart from each other. So for some reason you put electrical tape around that and it rubbed through, it's not going to touch exactly on a bare wire. It's still got the insulation of the other wire to go through. So we'll get these cleaned up, we'll put some insulation tape around them, run a bit of heat shrink tubing over that and seal that up, and I'll show you when we're about to install it. So wrap electrical tape around one connection on the negative side, electrical tape around the positive wire, and then we're just going to wrap the whole thing in electrical tape over both, and that'll just do a bit of abrasion resistance then. And I'm not going to bother about heat sinking this with heat shrink, sorry, because it's going to be undercover. It shouldn't get any rain on it. It should have pretty much no moisture. This electrical tape's quite good quality, so it seals up pretty well anyway. So I'm just going to do that. Alright, so this is the first courtesy lot we've got. That's going to come through here, mounted up that way, in there somewhere. So it'll come through here. So I'm just going to do a rough measure of how much cable we need. This will run underneath here. Follow all these cables later. So that's going to go up to there. There, up to there. Make sure we've got enough to go into the control panel. That should be plenty. So I'll just thread a rubber grommet through that, and we can thread that through, pot rivet that in, and start getting that installed. And we can run some cabling through here with the conduit now. Okay, so we've got a light here, threaded a grommet on there already. So what we can do is thread this through here, and I'll route the cable there. This cable has to go through to the control panel with the main feed from the isolator switch. Feed this through. Pop that grommet in there, that rubber grommet, stop the cables rubbing. Okay, so after a little bit of mucking around, we've got the grommet in and the light, and we'll just pot rivet that in there. So up under there I've mounted the Anderson plug. I didn't bother showing you how to drill that. It was pretty awkward to get to. Anyway, so I've put a couple of self-tapping stainless steel screws up under there to hold that. And then that cable is going to get run along the top of the gunnel there, through the seat. Through the top of the seat we've drilled a hole for some 13mm conduit. And then it'll come out here where all these circuit breaker blocks are and that. So I'll show you that on the next video. We've pretty much run out of time at the moment, so thanks for watching guys, and I'll see you on the next one.